Okay, hi everyone. I'm Kyle, and I'm going to be going over the Fall 2019 Data 8 final. I'm just going to go through all the questions and walk through how I did them. If you have any questions about this, you can email me at this address. I'll also probably make a Piazza post for this, so you can leave a follow-up there. I do want to give a quick disclaimer that I am not on the staff for this class, so everything I write here is not necessarily representative of the official solutions. They're just how I did it. Okay, so with that, we can move on to question 1. So this question's about Python expressions. I'm not sure exactly how these type of questions will be on the online final, because we'll have the interpreter open with us. But regardless, I still think it's good to get some practice with it. So let's look at part A. So it's np.count non-zero of np.arrange of 3. So first we want to know what np.arrange of 3 does. And remember, the arrange function can take in 3 arguments: a starting value, an end value, and the amount that you would jump by each time. But in this case, it only takes in 1 argument, and that's just where you stop. So it creates a range that starts at 0 and ends at this argument minus 1. So np.arrange of 3 is basically the same thing as typing make array of 0, 1, and 2. So now we're going to call np.count non-zero on this array. So np.count non-zero just returns the number of non-zero elements in the array. So in this case, 1 is non-zero and 2 is non-zero. So we have 2 non-zero elements. So our answer here is 2. So this one right here. For part B, actually let's draw this answer real quick. Okay. Part B is make array of 1, 2, and 3 multiplied by 2. So the nice thing about NumPy arrays is that we can do element-wise operations on them. So what that means is that if we add, subtract, multiply, divide an array by a number, each element in the array will have that operation done to it. So make array of 1, 2, and 3 times 2 means that each element in our array will be multiplied by 2. So 1 times 2 we have 2, 2 times 2 we have 4, and then 3 times 2 we have 6. So it's going to be an array with 2, 4, and 6, which is this answer right here. If we take a look at the other answers real quick, array 1, 2, 3, 1, 2, 3, this would be true if we were working with a Python list, where it'll repeat the elements, but in this case we're not. Remember that NumPy arrays do element-wise operations. Python lists will do something like this. And then here we have 1, 4, and 9, which is the result of taking 1, 2, and 3 and squaring each of those numbers. This would only be true if we had a second times sign here, because that would symbolize exponentiation. But in this case, it's just times 2. We only have 1 multiplication sign, so we're just multiplying, and we get our answer 2, 4, 6. Okay. Now, part C is np.arrange of 2, 8, 4 minus np.arrange of 1, 7, 5. So, as I alluded to earlier, np.arrange can take in 3 arguments. So the first is the start, the second one is the end, and the third is the jump. So what will happen is that it'll create an array that starts at the start value and will keep jumping by jump amount until you hit end, but not including the end. So right here, np.arrange of 2, 8, 4 would give the same thing as make array of you start at the start, so 2, comma, 2 plus 4 is 6. And then 6 plus 4 would be 10, but that exceeds the end, so we're done there. Now this one, np.arrange of 1, comma, 7, comma, 5. So here, we would start at 1, so it'd be make array of 1, and then 1 plus 5 is 6, and then 6 plus 5 would be 11, which is greater than 7, so we're done there. So now we have the array 2, 6, and then we're subtracting it from the array 1, 6. So again, with two arrays of equal length, we can do element-wise operations on them, meaning that we'll get a new array out that subtracts 2 from 1, so that's 1, and then it'll subtract 6 from 6 and get 0. So we should get array of 1, 0, which is this answer right here. Okay. Now we can move on to part D. So it's percentile of 30, comma, make array of 5, 10, 30, and 50. So the percentile function takes in two arguments. So it's percentile, and then the first element is which percentile you're taking, and then the second one is just an array, right? So the definition of percentile is the nth percentile, or in this case the 30th percentile, of an array is the smallest value that is at least as large as n% or 30% of the data. So we want to find the number in this array that is at least as large as 30% of the data in this array. So if we took 5, 5 is that greater than or equal to 5? Yes, but then it's smaller than each of the other elements. So it's only at least 25% of the data, because it's only like at least itself, but it's less than all the rest. So the answer is not 5. Then the second one is 10, and 10 is at least 5 because it's greater than 5, and it's at least 10 because it's equal to 10, but it's smaller than the other two, so it would be it's greater than or equal to 50% of the data. And this actually is the answer for this question, because it's at least more than 30% of the data. It's at least 50% actually, but it's also the smallest number that is at least 30% of the data. 30% or 30 and 50 right here, they are greater than more than 30% of the data, but remember, by definition, the percentile is, let's do it over here, nth percentile equals smallest value that is at least n% of the data. So by that definition, 10 would be the correct answer. Okay, so now the last one, part E, is np.std of np.arrange of 0, 200, 100. So the np.std function calculates the standard deviation of an array, and np.arrange, as we said, creates a range. So this would be the same as make array, starting at 0, and then you add on 100, and then if you add on another 100, you would get to 200, which is the max, but we don't want that, because we only want numbers that are less than the max, not equal to the max. So it would just be an array with 0 and 100. So now the standard deviation of this would be, well, the mean of 0 and 100 is 50. And then both of the deviations from the mean are 0 minus 50, the absolute value of that is 50, and then 100 minus 50, the absolute value is 50. So if we wanted to write this in code, we could say like deviations array equals make array of 50 and 50, because that's the absolute value of the differences. And then the standard deviation is the root mean squared errors from the mean. So we can square these. So deviations array squared equals deviations array all squared, which would give, let's see, this would be the same as make array of 50 squared is 2,500, comma 2,500. And then we want to take the average of it. So average squared deviation is deviations array squared we want to call the average, so np.average of all this, which would be 2,500 and 2,500. The average of that is just 2,500. And so the last step is to take the square root of that. So SD equals np.square root of average square deviation. And the average square deviation of 2,500 is 50. So our answer here would be 50. Okay, so that's it for question 1. We'll now move on to question 2.